Have you ever really thought about one of the most common elements on Earth? An element that you use every single day, in forms that are, well, complete and total opposites. First, just picture a simple pencil. You know, that soft gray stuff inside that lets you write? That's graphite. It's so soft, it literally just flakes off onto the paper. It's brittle, it's dark, you get the picture. And then you've got this, a diamond, the hardest natural thing we know of. I mean, this stuff can cut through solid steel. It's clear, it's brilliant, and it's one of the most precious things on the planet. And it gets even crazier when you put their properties side by side. Graphite is soft, diamond is incredibly hard. Graphite is black, diamond is see-through. Graphite can conduct electricity, but diamond is a total insulator. They couldn't be more different. So that brings us to the big question, the paradox. How on earth can two materials with opposite properties be made of the exact same stuff? Because that's what they are. Both graphite and diamonds are just pure carbon, nothing else. So what gives? Okay, so let's dig in. The secret to this whole mystery isn't really about what carbon is, but all about how it acts. It all comes down to how it connects with other atoms, how it bonds. You see, every atom just wants to be stable, to have a full outer shell of electrons. Carbon's kind of stuck. It's got 4 electrons in that shell. Trying to get rid of all 4? Nope. Takes way too much energy. Trying to grab 4 more? Its nucleus is too small to hang on to them. So what does it do? It comes up with the perfect solution. It shares. And this friendly sharing creates something called a covalent bond. Instead of one atom stealing electrons from another, they form a stable little partnership. It's really the ultimate win-win in the world of atoms, and carbon is an absolute master at it. And really, it all boils down to one magic number for carbon: 4. Because it has those 4 outer electrons to share, it's always looking to make 4 of these strong, stable bonds. That's its whole deal. And here's a perfect example of how that works. A carbon atom shows up with its 4 hands ready to link up. 4 hydrogen atoms, each with 1 free hand, come along. They all link up, everybody's sharing, and boom, you get a super stable molecule like methane. Everyone is happy. Now, sharing is one thing, but it's only half the story. Carbon has another ability, a superpower really, that makes it truly special. It's a fancy word called catenation. But what it really means is that carbon is incredibly good at bonding with other carbon atoms. Think of them like the universe's ultimate Lego bricks. They can just keep snapping together to build bigger and more complex things. So in the simplest case, carbon atoms can just link up one after another, forming these long, straight chains. This is the basic blueprint for a ton of organic molecules. But of course, it doesn't stop there. Those chains can have other chains shooting off from them, kind of like branches on a tree. This is how you start getting these really intricate 3D structures. And then for a final trick, a chain of carbon atoms can actually bend around and connect back to itself, forming these incredibly stable rings. These rings are fundamental building blocks for all sorts of things, from the smell of vanilla to the bases in your DNA. All right, so let's put it all together. We have these 2 superpowers. Carbon can form 4 bonds, and it can link up with itself endlessly. How does that solve our original mystery about the pencil and the diamond?
Well, here it is. The entire answer is in the arrangement. It's the architecture. In a diamond, every single carbon atom is bonded to 4 other carbons. This creates this incredibly strong, rigid 3D web. That's why it's so hard. But in graphite, each carbon only bonds to 3 others. This forms flat sheets that can easily slide over each other. And that 4th electron, it's free to move around, which is what makes graphite soft, slippery, and lets it conduct electricity. Same atom, completely different blueprint.
And this basic idea, how carbon connects, doesn't just explain diamonds and graphite. It explains the world. When carbon links up with hydrogen, for instance, you get this huge family of molecules called hydrocarbons. And depending on how they bond, single, double, or triple bonds, they create everything from the fuel that runs your car to the plastics you use every day. But carbon's role goes so much deeper than just fuels and materials. Its knack for building complex, stable things makes it the foundation for, well, for us. I mean, carbon is literally everywhere. It's in the rocks under our feet, it's dissolved in the oceans, it's in the air we breathe as CO2, and maybe most importantly, it is the fundamental structural atom of every single living thing on this planet. And that's exactly why we call the chemistry of life organic chemistry. It's really just the study of carbon compounds. Its unique talent for sharing and for linking up with itself is what allows it to build the incredibly long, complex molecules like proteins and DNA that life absolutely depends on. So it all comes back to this, from the soft lead in a pencil to the brilliant diamond, from simple fuels to the unbelievably complex code of our own DNA. Carbon's versatility is just staggering. And it leaves us with this one final, massive question. Is carbon just the most convenient element for building a world like ours, or are its unique superpowers the only recipe that could have made life, as we know it, possible?
If you liked the video, make sure you like, share, subscribe, and not to forget about commenting your favorite part. And at last, I want to say,
we will be meeting soon, and stay royal, yippee!